Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, nama budaya dan salam kebajikan bagi kita semua. Perkenalkan, nama saya Gede Arisma Dinata dengan NIM 19055531131. Baik, di sini saya akan mempresentasikan materi tentang Advanced Mechaning Process. Sebelum lanjut ke Chemical Mechaning, proses permesinan yang telah dijelaskan dalam bab sebelumnya melibatkan material, penghapusan dengan cara mekanis, namun ada situasi di mana metode mekanis tidak memuaskan ekonomis atau bahkan mungkin karena alasan kekuatan dan kekerasan material benda kerja sangat tinggi. Jadi yang pertama dari chemical mechaning adalah yang tertua dari proses permesinan canggih dan telah digunakan dalam mengukir logam dan batu, dalam deburring, dan dalam produksi papan sirkuit tercetak dan perangkat mikroelektronika. Baik, pada gambar yang sebelah kiri itu ada gambar benda yang sudah mengalami chemically cleaning area, yaitu pada bagian yang hijau yang sudah ditunjukin pada bagian tersebut. Untuk gambar yang tengah itu adalah sebelum dan sesudah mengalami chemical mechaning. Yang 4 mm itu adalah benda sebelum mechaning. Terus yang 2 mm tersebut adalah sebelum sesudah mechaning. Pada gambar yang sebelah kanan itu adalah gambar roket. Di bagian badan roket itu ada 3 titik bagian di badan roket itu yang yang mengalami proses mechaning, yaitu bagian atas, tengah, dan bagian bawah, bertujuan untuk meringankan bobot dari jet tersebut dan menambah daya elastisitasnya juga. Baik, di sini adalah video yang dari mechanical mechaning process.
The first thing that needs to happen for a part to be chemically etched is for there to be artwork generated. Drawings are taken from computer data and photo-plotted onto film, creating areas on the film that are either black or clear. Depending on the type of photoresist being used, either the clear areas or the black areas will be the image of the desired part. Generally, there are 2 pieces of film created that are aligned precisely front to back. Metal is then selected, then sheets are cut to match the size of the film created. The metal is then cleaned to remove any residual oils and oxides. It is very important to have clean surfaces on the metal to make sure the resist that will be applied will adhere successfully. The sheets are then coated with the photosensitive resist. The resist is sensitive to UV light and resistant to acid. After the resist is applied, the material is then placed between the 2 pieces of artwork that have been created. The resist-covered sheet is then exposed to UV light to create the desired image on the coated metal. Generally, where the light shines through the clear areas of the film, the resist is exposed and becomes hardened. Where the resist is shielded from the light by the black areas of the film, the resist remains soft. After exposure to the UV light, the sheets are put through a developer where the soft resist is dissolved away and the hardened resist remains. The sheet of material will then have resist remaining in the areas where the material needs to remain, while the rest of the sheet has exposed metal where the material is to be removed. The next step is to have the sheet put through an etching machine, where etchant is sprayed on both sides of the sheet. Where the etchant comes in contact with exposed material, the metal is dissolved. Where the resist has been applied, the material will be protected from the etchant. When the sheet is finished etching, the remaining resist must be removed. This is done by applying resist stripper, which dissolves the resist. The result is the finished edged part.
Oke, mungkin segitu saja gini proses dari mechanical machining. Terus lanjut ke electrochemical machining. Electrochemical machining atau ACM pada dasarnya adalah kebalikan dari electroplating. Elektrolit bertindak sebagai pembawa arus dan kecepatan tinggi bergerak elektrolit di celah alat benda kerja biasanya tuh 0,1 hingga 0,6 mm mencuci logam ion menjauh dari benda kerja atau anoda sebelum mereka memiliki kesempatan untuk menempel pada alat atau katoda. Pada gambar sebelah sini nih, yang pertama tuh ada workspace. Di workspace itu bakal dialiri arus positif dari DC power supply. Terus yang dialiri arus negatif itu adalah bagian dari bagian coatingnya. Terus di bagian coating itu ada tools. Terus di area coating itu bakal dialirin elektrolit yang terus dipompa. Pada bagian ini adalah di sini dia saya lihat pada bagian bawah ini di antara celah-celah yang hijau sama yang ini tuh ada di sana tuh maksudnya tuh harus bergerak di sana untuk mencuci logam ion menjauh dari benda kerja itu bagian sana. Mungkin bisa lebih jelas bagian kita bisa tonton pada video kali ini.
Electrochemical machining process. Electrochemical machining, or ECM, is a method of removing metal by an electrochemical process. It is normally used for mass production, and is used for machining extremely hard materials, or materials that are difficult to machine using conventional methods. Its use is limited to electrically conductive materials. This video will cover the following about electrochemical machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. Working principle. Whenever the two electrodes, anode which is connected to positive terminal, and cathode which is connected to negative terminal, is immersed in an electrolyte, such as NaCl. When the voltage is applied across the two electrodes, the material removal from the anode starts. The anode and cathode is placed very close to each other without touching. In ECM, the material removal takes place at atomic level, so it produces a mirror finished surface. ECM working is opposite to the electrochemical, or galvanic coating, or deposition process. Let us understand the chemical reaction taking place in this process. As the potential difference is applied across the electrode, the movement of ions starts in between the tool and workpiece. The positive ions move towards the tool, and negative ions move towards the workpiece. At cathode, the hydrogen ions takes electrons, and gets converted into hydrogen gas. In the same way the iron atoms comes out from the anode which is workpiece as Fe++ ions. Within the electrolyte, the sodium ions combines with hydroxyl ions and form sodium hydroxide, and ferrous ion combine with chloride ions and forms ferrous chloride. Also iron ions combine with hydroxyl ions and form iron hydroxide. In the electrolyte, the FeCl2 and FeO2 produced and gets precipitated in the form of sludge and settle down. In this way, the material is removed from the workpiece as sludge. The various reactions taking place in the electrochemical machining process are as follows. Construction. Electrochemical machining setup consists of following parts. Power supply. It requires a DC power supply for machining purpose. Electrolyte. The electrolyte has three main roles in the ECM process. It carries the current between the tool and the workpiece. It removes the products of the reaction from the internal electrode gap, and it removes the heat produced from the passage of the current. Tool. Tool is a replica of the shape required on the workpiece. This holds the electrolyte in which the tool and workpiece are